welcome. Glad you're here. Honestly, probably out of all the technologies that I personally work with, Kubernetes is definitely in the top 5. Is one of my favorites. Okay, I've been working with Kubernetes since the early days. Actually was working with it before a lot of organizations decided that they wanted to take Kubernetes into a production type of a setting. Okay, it's back in the same time period where I think Docker was still in its questionable growth of should we use this in production or not, right? Because those days did exist. And I think probably there's folks in here that remember those pretty well. I'll give you a kind of a verbal intro on some content, and then I'm going to take you through some of this content that we have right here. One thing that I will point out is that WebAge has done a great service, in my opinion, to you because the content that they've given you is what we use in courses, okay? So that's really good. So you should have plenty of information to actually work with. Also, just so you know, I will be using a local Kubernetes cluster. Okay, so we'll talk about that. So just to let you know, I'm actually running Docker Desktop, and right now really don't have anything running in it at this point in time. I am going to take you through stuff that exists in some of the course content that I use whenever I'm teaching Kubernetes, and we'll talk about best practices in context of that. The last thing that, by the way, that we'll talk about is what I see as some of the futures in Kubernetes. And actually, in my opinion, that's fairly straightforward because we see that evolving kind of almost monthly. Okay, we see some of these spaces actually happening right now. So that's my introduction. Again, name's John from Dallas, and feel free to interact as much as you want to. Use chat. Come off mute. And let's see here. And I'm gonna get, oh, yeah, and so do me a favor, you guys that can hear me talking, can you confirm for me in chat? Nobody wants to put anything in chat. Yes, I can, because we are not on mute. All right, hang on. All right, so hopefully we're going to check on that. Okay, Albert. All right. Just making sure. All right, I just want to make sure because there are folks out there, it looks like they have question marks next to all right, so good. Awesome. I see the feedback now. All right, so anyway, one thing that if you would, if you have any interaction, use the chat. The questions in the GoToWebinar is kind of wonky. I'll take them either place, but nonetheless, the best one to interact with is definitely the chat. All right. So all that being said, let's go ahead and dive into a little bit of Kubernetes architecture. And as I mentioned to you, I'm going to include in here some of our best practices as they become relevant in discussing Kubernetes. Okay, so one of the things that we always begin is we always begin with a container runtime. Okay, now one thing that I want to make really super clear at this point in history, Kubernetes is no longer shipping with the Docker runtime. Okay, that may be news to you, that may not be news to you, but the Docker runtime actually is no longer the center of the universe as it comes to Kubernetes. Kubernetes actually is in the mode of actually supplying their own optimized container runtime. Okay, the beautiful thing is that you and I can still do our builds and stuff like that with Docker and still produce images that we can use in our Kubernetes world. Okay. So first and foremost, as Kubernetes enters the market, really since the beginning of the year, Docker is no longer the primary runtime for containerization. Okay, so we're going to start off and talk about a little bit of the Kubernetes basics. We'll talk about its components, and then we're going to talk about best practices in the context of that. Okay. So first and foremost is some basic definitions, okay? As you can see there on my screen, Kubernetes is great for helmsman or pilot, which is very interesting, okay? I haven't even gotten into the deep introduction on Kubernetes, and we quite frankly already have a best practice when it comes to enterprise Kubernetes, okay? And that best practice for enterprise Kubernetes is actually utilizing a tool called Helm, H-E-L-M, okay? So Helm fits right into that nautical theme, okay? And is a tool that helps treat Kubernetes components as packages, okay? I'm going to come back to this a little bit later on, but I always mention that whenever we talk about the fact that Kubernetes is already in that space of talking about helmsmen and things that are nautical, okay? You'll notice the basic history of it, and most often associated with Docker. That's very true, though that is not the container runtime that Kubernetes is shipping with anymore. I think you get the idea. So the initial comparison that we often make with Kubernetes, and quite frankly with containers, is between virtual machines and containerization. The reason that we like containers so much is that they are so efficient. They're very fast. They start up quickly. Once I have an image for a container on my machine, to start up a new instance of it is very quick, and they're very lightweight. Okay, so if if I do a Docker run and I'll do it in the background, and I'll go ahead and use Nginx, right, like that. I'll let that go ahead and start up. You see how quickly that and I'll do a Docker container, and I'm showing you the basics of this just as you'll need just to kind of give a reference point. This is one of the reasons that we love Kubernetes so much. It's because of what it's built on top of. It's built on top of the container runtime. It's not as heavy and it's not as thick as virtual machines. You'll notice that the image that I just started, right? Actually, let me rephrase that. The container that I just started from the Nginx image, the image itself is 142 megs, right? The container that I just started is only 109 kilobytes, okay? So if I say, hey, let's start up even another container based upon that same image, you're going to notice that both of them, as far as the additional size that they take up, is 1.09 kilobytes. They're both using and leveraging a shared image, okay? So quite frankly, this is a significant benefit for container-based technologies. Okay, now as the story goes, and actually I'm trying to just essentially quickly clean up on it. 8CE 84323. Let me see if that takes care of it. There you go. Just trying to keep things clean. So back in the day, we got excited about Kubernetes and said, or not Kubernetes, but Docker, and said, hey, I want to use this in the production. Okay. One of the problems with running Docker in production is managing it across multiple machines. Okay. So Docker has a very nice networking capability. All containers that you start up on the same machine are in the same network. Well, what happens when they cut across nodes, cut across machines, right? So I need somebody to handle that. Okay, I need some kind of infrastructure to take care of that. What about scheduling? What if I have 50 machines out there that I want to run workloads on, Docker containers and Docker processes, right, that I've built? I need something to manage that for me, okay? Docker provided a capability called Swarm, S-W-A-R-M, but it does not do quite a few of the things that Kubernetes does for us. Kubernetes takes care of handling this at the enterprise level, okay? So that is one of the core concepts that exist in Kubernetes. The other one is the fact that whenever we use Kubernetes, typically we're an organization that has said, hey, let's go the microservice architectural pattern route. We want to build everything as microservices, right? We don't want to have one big gigantic deployment anymore. We want to build individual deployments that together make up our application. Well, that's a good thing if I have something I can use to manage it, okay? So I need something that can essentially do some basic things for me. Service discovery is one, load balancing is another. Property management, in other words, managing configuration variables and things like that. Typically in the old days, we used property files for this, but I can't have an application that is distributed and my property files are spread all over the place. So I need something to help me manage that. These are also elements that Kubernetes provides. So not only does it give me an environment that I can use to distribute my container workloads, okay, if you will, across multiple machines, but it also provides a way for me to solve quite a few of the microservice challenges that we have, okay? And Kubernetes does do that for us, okay? So obviously, open source system, that's a beautiful thing. It is designed to scale. We like that. The other thing is that it is also designed to be a core element in your DevOps lifecycle, okay? So doing things like creating new apps, updating existing apps, these types of things is intended to be made easier with a tool like Kubernetes, and that's exactly what Kubernetes does for us, okay? So there are two main kind of component areas in the Kubernetes architecture, okay? And that's what you're kind of looking at right here. On the left-hand side, you have the control plane. On the right-hand side, you have all of the nodes that your workloads are actually running on, okay? So I'm gonna go ahead and give you another best practice right here, my friends, okay? Remember I told you I was gonna give those to you in context, okay? So every one of the cloud providers that we might use, from Google to Amazon to Microsoft Azure, all have native Kubernetes services that they provide to their customers. Okay, so I can go out to AWS and I can actually create an EKS cluster, which is a Kubernetes cluster, and Amazon will supply the control plane for me, and then I personally, from my account, will pay for all of the nodes that I need in that cluster. Okay. Why do I even bring that up at this point? Well, the reason I bring it up is because this control plane, if the control plane goes down, then you cannot manage your workloads. Okay, and so the control plane needs to be up. The other thing is that the control plane has a kind of a NoSQL database table where all of the information about the deployments is actually stored. Okay, so the fact that if I deploy to one of the cloud providers and that I get redundancy in the control plane, basically AWS, Azure, GKE, they're going to make sure that the control plane is resilient. That's a very, very good thing for me. Okay, I really don't want to manage that on my own and have to take care of it for me, or have to take care of it by myself in my own data center. So one of our best practices truly is use a cloud provider's Kubernetes implementation. The beautiful thing about it is that if I'm using AWS's EKS, and then later on we decide that our company is moving over to Azure, then I can take my Kubernetes-based workloads out of AWS and I can deploy them into Azure's AKS without skipping a beat. Okay, the only main conversion that I'm going to have to worry about at that point is going to be with my data. Okay, so I guess that's best practice. What, number 2 is use a cloud provider. Okay, the other thing is that all of the cloud providers now are providing the capability that rather than having a virtual machine for each one of my nodes in my Kubernetes cluster, we can now use and the technology name differs by cloud provider, but it's serverless. Okay, so all the cloud providers now offer a serverless capability in context of working with their Kubernetes technology. Okay. All right. So back to the architectural diagram. On the left-hand side, control plane, and then on the right-hand side, you have all of the nodes. The nodes that you have right there, I see we have 3. If I am on one of the cloud providers, then I can add additional nodes if my compute needs increase. Okay, so if I need another, machine compute capability to handle the workloads that I'm deploying, then we can have the cloud provider spin up another virtual machine, or we can expand the use of serverless to handle that workload. Okay. All right. I'm assuming everybody's okay so far. Again, if you have a question, throw it out in chat, come off mute. Glad to have them. All right. So what I do need to do, and what I do want to talk about to make sure that you understand, is the components that are sitting over there in the control plane. Okay. And so we have several different components that are in the control plane part of Kubernetes. Okay. And you see them listed over on the right-hand side. Okay. And then there are some components that exist down on every single one of those nodes that I also want to call out to you. Okay, so the control plane has an API server. The API server is essentially a REST server, right? That handles API calls from your command line client or from Helm to manage and handle your deployments. Okay, so the API server is kind of central to the Kubernetes world, and you'll see it real faintly right there. Okay. You also have the if you're deployed in one of the cloud providers implementations, okay, you have a cloud controller manager. Okay, you'll notice that it is listed as being optional. What the cloud controller manager essentially does for us is it integrates Kubernetes with your cloud provider. Okay, so if Kubernetes identifies that there's no more space left, processing and memory wise, to actually deploy a brand new application, then it can send a signal to the cloud provider to spin up a brand new virtual machine or allocate more serverless capabilities to handle the workload. Okay. Something else that comes into play about that's running on the control plane is what is called the controller manager. Okay. Now, Kubernetes by default is a declarative model. Okay. So if I was to go in and look at one of the deployments that I have, you'll notice it's all YAML. Okay, and I think that those of y'all that have worked with Kubernetes, you know this. Okay, but the reason that this is a good thing for us is because these YAML files are basically describing the deployment that I want to be created on my Kubernetes cluster. Okay, and so what the controller manager does that we're talking about right here, essentially what the controller manager does is it makes sure that what is actually running in your cluster is what you said you wanted. Okay, so it's basically constantly looking at your manifest in comparison to what is actually running out there. Okay, and in the event that you change something, okay, then basically the controller is going to make sure that that change takes place. Okay. Let's see, Shalish, you're asking a great question out there, my friend. Yours is when you say KH native service provided by a cloud provider, does it mean that there is no additional charge to use this? So and I'm glad you asked that because we want to make sure that this is really clear. When it comes to Kubernetes in our cloud providers, we're usually not charged a whole lot for the control plane, okay? Because quite frankly, the control plane it has some components that are fairly straightforward for Amazon or Microsoft or Google to actually host. What you and I are charged for is the compute, right? So I think that their accountants have done the math to basically get the idea that if we give you some breaks in the control plane, we'll more than make up with what you spend on compute when it comes to Kubernetes. So great question, great question. All right. So the controller manager, we just got through talking about what that does, okay? So one thing I want you to understand about the infrastructure that Kubernetes basically implements, it is very much a loosely coupled infrastructure, okay? So the API server receives requests from the client, okay? So whenever I do, something like, a Kubernetes command where I'm getting a list of everything that's out there, that's making a call against the API server, okay? So the API server receives the communication that's necessary from the components that make up the system. Each one of the other components has a specific role that it plays, okay? So you'll notice that the cloud, actually the controller manager, which is this guy right here, is responsible for making sure that your manifest files that you've deployed in the Kubernetes match what is actually running out there. Actually, let me say that a different way. It makes sure that what's running out there matches your manifest, okay? Because your manifest is basically the contract. You're saying what you want, okay? And the controller manager makes sure that what is running on the cluster matches that manifest file, okay? All right, everybody good? I'm taking it, awesome. All right, so based on that, there is got to be a place where information about the deployments that you've made are actually stored, right? Well, that's what etcd is used for, and that's what this one is right here. etcd is essentially a really fairly straightforward NoSQL table that holds all the information about what manifests have been submitted and what their current status is on your Kubernetes cluster. Okay, so basically, it's your persistent store that Kubernetes uses for management purposes. Okay, all right. Last but not least, on the control plane is that one at the bottom. It's called the scheduler, okay, right before the control plane. So the scheduler is responsible for determining where the workload that you're submitting is going to run, okay? Let me go ahead and inject best practice number 3 for you then, okay? So if the scheduler has the capability to choose any one of the nodes that is a part of my Kubernetes cluster to run your workload on, okay, it means that at another point in time, if let's say your workload has a problem and it goes down, then the scheduler could be called upon to reschedule your workload onto a different node, okay? You want to build your services that you're going to host in Kubernetes in a stateless fashion, okay? Statelessness is going to be one of your best friends when it comes to working with applications that you're going to deploy in this environment, okay? Don't build something, okay? Do not build something that requires that every time that it's scheduled, or if it has to be moved because there's been a problem in the architecture, the ecosystem, or in the running workload itself, don't hard code anything in there that requires the same machine to be used every single time, okay? And also don't put anything in there that holds data in memory in the application tier, okay? When it comes to data storage in Kubernetes, you want to separate it from the application tier, okay? You don't want to do what we used to do in the Java world back in the day, where we'd have a web session and we'd put a ton of stuff in the web session. That day is over with. We don't want to live that way. We want to take any storage that we need, any persistence that we need, and we want to separate it from the application tier. Okay, so if you want to talk about a really important best practice, the way that you design that application, you want to approach it in a stateless fashion. No state should be held in the application tier. Okay, you really want it to be separate from that. All right, which obviously means that any data storage that I have obviously is going to be in a database service, maybe running in the cloud, or it could be a database service that's being hosted by another container. Where that data is actually stored should never be stored directly on the hosts that are running these workloads. They should always be stored external to these machines onto, I don't know, the, AWS's data services, right? Could be relational, could be NoSQL, but I think you get the idea. Separate out your data tiers from your processing tiers, make your processing tiers stateless, okay? It's an incredibly important, and your life will be a lot better if you follow that rule as well, okay? And by the way, just to let you know, I'm going to give you a lot more than 5 Kubernetes best practices. I'm going to give you the ones that, having worked with several decent sized companies that we've learned, okay? So I've had the opportunity to work with like Starbucks, Walmart, VMware, and other companies like that. I want to make sure that we take the best practices that came from those companies and we actually bring them in to our discussion right here. All right, so I've talked about the API server, talked about the cloud controller, talked about the control manager, talked about the etcd, which is our storage, and I've also talked about the scheduler, okay? And remember, what the scheduler's purpose in life is to determine where your workload is going to run, okay? And we'll talk more about components here in a minute. So those are all elements that are running on the control plane, okay? So basically, they act as the controlling elements that basically are used to manage the workloads that you have running on Kubernetes, okay? Now, on every single one of the nodes that is a part of your cluster where the workloads are actually running, okay, and I want to make sure that we're real clear about this, your workloads will never run on the control plane. They'll never run on the master server, okay? They will always run on one of the nodes, okay? And in order to facilitate that, the node has a couple of elements that are running on it to make that possible, okay? The first element is called kubelet, K-U-B-E-L-E-T, okay? Basically, kubelet acts as an agent for the Kubernetes world, okay? And I'm going to walk you through kind of a workflow on how the scheduling happens, and you'll see where kubelet comes into play, okay? But kubelet is running on every single node inside of your K8's cluster, okay? The other thing that's running on those nodes is a proxy, okay? A proxy service is there to manage networking because might as well talk about it, right? It's important to understand the way the networking is done in Kubernetes, right? Is that if you remember the containers in Docker, every container can be seen by other containers when they're on the same network, okay? And that network can cut across hosts. Well, Kubernetes operates no differently than that, okay? So in order for routes from one component, one workload running on one node to be routed to a workload running on another node, okay, there has to be some type of mechanism that makes that routing information available and makes that routing actually possible. And that's what the kube proxy actually does, okay? So those are all your components, my friends. And what we have 3 best practices in so far, not bad for the first 40 minutes, okay? So let's keep rolling. All right. So if you're looking for a list of best practice, or not of best practices, but about the components that are within inside Kubernetes, this is a great list. And guess what? You're going to get some more best practices out of this list. So cluster, basically, We're going to have possibly a couple of master nodes if I'm hosting it myself and I'm trying to develop redundancy. If I'm operating in a cloud provider's implementation, the cloud provider takes care of that redundancy for me. And we also have the worker nodes. The worker nodes, want to make sure you're really clear on that. Worker nodes is where your workloads, your code that you've written, that you've packaged is actually going to run, okay? All right, so that's the entire thing. That's the entire, cluster itself. The master node, which is our control plane, basically is the management infrastructure for K8s, okay? The worker node, okay, which is either going to be a virtual machine. Obviously, if you're in the cloud, it could be physical if you're hosting your own cluster, or it can actually be serverless. Basically, is where all of the workloads that you have deployed are going to be. Okay, all right. Now, when it comes to Kubernetes, as most of you probably know, we do not work with containers. We actually work with pods, POD, okay? A pod usually abstracts one container, but it can be more than that, okay? So a pod can manage either one container, right? One Docker, if you will, container, or it could be multiple of them, okay? And basically the pod is going to be created and managed by Kubernetes, okay? So if you want to see, if you have not seen it, this is what a manifest file looks like for a single pod, okay? So you'll notice that's my pod definition. I give it a key value pair right here, which is a label, and then I specify the name or the image that I want to run inside the pod, and I give the image a name. Okay, and so basically, kube cpl apply -f pod.yaml. Okay, fantastic. I now have a pod running on my Kubernetes cluster. There you go. It's creating the container right now. If I go back to it a couple of times, sooner or later, trust me, the container will be up and running. There you go. Fantastic. So a pod is basically representative of my workload, okay? And it's pods that basically run on all of the worker nodes that exist inside of my cluster. There you go. Really fairly straightforward. Containers, though it says commonly Docker containers, that's no longer the case, okay? One of the discussions that that we kind of targeted for yeah, Samuel, hang on a second. I just saw your question out there. One of the examples that we're talking about when it comes to containers. Docker is often used as kind of the main discussion when we talk about containerization, okay? But as many of you probably already know, it is not the only game in town as far as container technologies. Containers basically are built on top of what's called the Open Container Initiative, which is called OCI. And there are several container runtimes that you and I could actually leverage in order to maybe facilitate, a different type of behavior in the container than what we normally would get with Docker, okay? So I can still build everything with Docker. The images that I build with Docker are OCI compliant, and I can pretty much run them on just about every container runtime. All right. Samuel's asking a really good question out there, and it is, can you share any relevant examples, demos, explanation of serverless worker nodes? Yeah, actually, and I don't know exactly maybe what you're looking for there, but I am going to take that as an opportunity, okay? Hang on one second. Let me bring this back up. All right. Yeah, this is really, really good. That's a really good question, Sam. I appreciate you asking that, my friend. So all of our cloud providers have different technologies for serverless, okay? The technology of choice, obviously, out on AWS is Fargate, okay? So basically, we can, instead of creating virtual machines for our Kubernetes cluster, we can actually specify that our cluster is utilizing Fargate for the execution of our pods, okay? The scaling obviously is going to happen just a little bit differently than how it would with virtual machines, but there's still the capability around Fargate for managing metrics, the amount of CPU that you're buying, the amount of memory that you're buying, and so you can set up a Fargate profile that your cluster actually utilizes, and then the cloud controller works in conjunction with that Fargate profile to make sure that you have enough resource to actually run your workloads, okay? And so it becomes an on-demand type of an environment, right? Hopefully that's kind of what you're looking for. Yeah, and all of them, if you're also looking, and I think I may have mentioned this before, maybe I haven't, but one of our futures is we're going to see Kubernetes move more and more to serverless. Okay, that utilization is still fairly young today, but you're going to see it used more and more, and you're going to see both AWS, GCS, and Azure begin to roll out more integrations to make that even tighter. Okay, all right. So pods and containers, you got that. You bet, Sam. Thanks for asking it, my friend. Containers, great. We got all that. Volumes, okay? And we're going to talk a little bit about volumes in a couple of ways here. Basically, this is what I can use to store data, okay? The directory that you create with a volume is available from within inside of your pod, okay? So if your code that's running inside of the container that is being run inside of that pod, okay, just remember how that fits together if you're fairly new to this. Pods have containers, right? Pods basically are the Kubernetes abstraction for the container. The container can actually mount a volume, okay, for direct file system access for maybe data that you want to write out or read from. If you and I are operating in a production environment, that volume should not be a volume that is local to the machine that is running on, okay? So this is like best practice number 4, I think. Volumes should be externally mountable storage devices, okay? And what I mean by that is you can mount a volume. I'll use AWS as an example. You can mount a volume in Kubernetes to Elastic Block Store, EBS. You can also mount a volume to EFS, okay? So that the running container could actually read and write to EFS or EBS directly. It can be, it could actually be done with a normal file system remote mount, okay? You can do it that way as well, okay? So key thing when it comes to volumes and Kubernetes, you really want to be using the shareable drive capabilities that exist out there. And if you want another reason that it is a best practice to run on a cloud provider, this is another one, okay? Kubernetes, and I'm slowly but surely making sure that my thought is correct on this, and it is. Kubernetes integrates with just about every shared storage system that is on every one of our cloud providers that we might want to use, okay? So I can use it with, technically I could use it with Amazon S3, EBS, EFS, you get the idea. I can do the same thing over on Azure. I can use its storage solutions over there. Same thing with GCS, several of Google's, okay? So best practice when you're using volumes, you actually want to be using the cloud providers' shareable volume mechanisms. What this does for us, just so that we're really super clear on this makes it possible that if I have a shared volume that's accessible from any one of my worker nodes inside of Kubernetes, then my workload, right, my pod could be run on any one of those nodes. It doesn't matter. And if a pod fails on one node and has to be rescheduled onto another node, that's not a problem either, because we're dealing with shared storage rather than storage that is specific to a particular machine, okay? So I'm assuming everybody's okay with that. So you've got clusters, you've got your master, right, which is your control plane. We've got pods. That's awesome. Pods basically are Kubernetes abstraction for containers. And by the way, if you think about it, this actually makes a ton of sense, right? Kubernetes can work with pretty much any container runtime. So there has to be some type of abstraction that exists between the Kubernetes ecosystem and the container runtime. Makes total sense, right? So literally, that's why Kubernetes architecture focuses on the pod. I can use any container runtime that I want to. If I get tired of Docker, I want to use something else, it's not a problem. I can do that, okay? All right, so you've got containers, volumes, pods, you got the control plane and the nodes. That's beautiful, got the cluster. What best practices are we on now? Are we on 5? Okay, namespace. Okay, so by default, okay, whenever I have a cluster, okay, by default, there are a few namespaces that are actually created, okay? And just to make sure that we're all on the same page with this, essentially a namespace is, if you will, a virtual cluster, okay? So basically, whenever I do a deployment, I do my deployment to my namespace. You do your deployment and you do it to your namespace, okay? We all know what namespaces do in different technologies, right? They make sure that we don't have name collision, right? So that if you name your pod XYZ and I name my pod XYZ, that we're not gonna have a name collision because they're in 2 different namespaces, okay? You'll notice that there is a default namespace that exists in my Kubernetes cluster that I'm currently working on, okay? See how strongly can I word this? But this is there's lots of best practices around this, my friends, that I'm going to mention. You should not deploy workloads to the default namespace, okay? So whenever I did this command right here, whenever I did my apply, right, you'll notice that I did not associate it with a namespace, okay? I did not do that and give it a namespace name, okay? Because I didn't, it was deployed to the default namespace. And so if we deploy everything to the default namespace, we're gonna have a name collision, I can guarantee you that. But there's something else in here that's even more important than that, right? But wait, there's more. So let's get our best practice codified here, right? You should never, and I do mean never, do a deployment to the default namespace. All of our deployments inside of our organization should be done to a specific namespace. There are many reasons for this, okay? One of the reasons is because I can associate security at the namespace level inside of Kubernetes. So I can make it so that only certain people that are part of a certain group can access that namespace. And then I have some more granular security on top of that, where I can specify that, you know, maybe you can list all of the components that are in the namespace, and maybe I am the one that can actually make changes or create. So we have the capability to set security at the namespace level. Okay, we'll talk a little bit more about kind of that security components here in a little bit, but you get the idea. Use namespaces. Okay. All right. Something else that I want to mention at this point. Whenever you deploy your workload, okay, which essentially ultimately is an image, right, to Kubernetes, your pods, the container that your pod is managing can use as much of the resources that are on that machine as you allow it, okay? Remember, when it comes to Docker and Kubernetes, there is no hypervisor, okay? There's no virtualization of memory and CPU. The pods running their containers on your nodes inside your cluster have full access to the resources that are running on that machine, okay? So what you and I can do at the namespace level, we can set limits. How about that? And this is kind of an important concept when we're dealing with the enterprise. So what it does is it allows me to create a namespace and maybe identify that that namespace can use up to 20% of the cluster's resources, whereas another namespace may be able to use 40% of the cluster's resources. You know what I mean? So I can manage resource utilization across namespaces, and I can do that at the namespace level. Very, 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 very important. Okay. All right. And you guys are more than welcome to throw any questions that you have, you know, out there at any point on any of the stuff that that we bring up. I just want to make sure that everybody's clear on that. All right. So now that you have yet another best practice, right? Use namespaces, okay? That namespace is a very important element for creating a separate place for your workloads, okay? All right, Sam, good practice, utilize namespace to separate deployment environments. It can be, yes. So Sam, taking that a step further, I'm assuming that we're talking about dev, test, prod, right? So there's two ways that I can do that, that I can separate out dev, test, and prod, right? Is I could create physically different clusters for that, okay? And that's fairly straightforward to do in the cloud environment. Or I can have one cluster, and on that cluster, I have different namespaces for, you know, dev, test, and pre-prod, right? Usually I'd want to make prod a totally separate cluster, but yeah, that's not a bad way to leverage namespaces, right? It's a great question. Great question. Keep things separate, and that's what it does for me. And by the way, in Kubernetes, Kubernetes really does not have a hierarchy of components. Okay, so there's no nested component type of hierarchy that we traverse when we're doing or when we're looking at logs, performance, all that kind of good stuff. So using namespaces can be a good way to do that. So pretty much all of the monitoring utilities that we might want to use within inside of Kubernetes, pretty much all of them allow us to monitor at the namespace level within inside of the cluster. So that's a good thing. So I can monitor individual as well as namespace. Okay. All right. Let's do real quickly. Okay. Let's do a quick kind of stand up break until let's say 2:05 EDT. Okay. Let's do that. This gives you a chance, run to the restroom, do whatever you need to do, come back real quick, and we're going to pick up from here and grab some more content on Kubernetes and some more best practices. All right, so little quick break there. That's good. Good to get us good stand up, kind of walk around a little bit. We don't want to be sitting all the time, right? We have a couple of other items that are really kind of important for us. The first one is the label, okay? And the label is a very important element, okay? And I'm gonna walk you through a demo of that, how we use them. Annotations, basically metadata that we can associate with objects, okay? And controllers, basically, which are used for configuration to identify the health of the cluster and all that kind of good stuff. Okay. Is the namespace typically at the same granularity as a container? Jensen, no. Think of it as a namespace has multiple pods that are running in it, and each one of those pods are running their own containers. Okay. So basically, a namespace is a grouping mechanism that we have to separate out some of the elements that we care about in a runtime type setting. Okay. So Kubernetes, as of the beginning of the year, okay, I think Kubernetes actually is utilizing their own runtime. There was talk about Kirk about continuing to leverage Docker just because Docker wanted to keep their, obviously hand in the center of the market. So real quickly, Vamsi, okay, and I appreciate you saying that. I should be actually throwing those down, right? Actually, I'll keep my own chart up here. Kirk and Jensen, if I didn't answer sufficiently, please let me know. Okay. And Vamsi, I'll come back real quick. Namespace is isolated. Pods in one namespace restricted from networking with parallel namespaces. The answer to that is no, they're not. But we can provide security for networking across namespaces. How about that? So they're not 100% isolated, but they can be, okay? So you have some control over that, which is a good thing, okay? All right, so things that I've mentioned so far, probably the most important one, the most important best practice is the use of a namespace, okay? Under no circumstance, and I think I can be that strong with my words on it. Under no circumstances should a production deployment ever be allowed into a non-namespace type of environment. As a matter of fact, to give you a perfect example of infrastructures, Walmart basically ties the namespace with the Active Directory group that the developers that are building the application are associated with. Okay, so that's how the security is actually correlated between the two. Okay, so namespaces are actually critical, and they are very important, and they're also important from a resource utilization management type thing. Okay. I also mentioned volumes. Okay. In that volumes, excuse me. So volumes are basically ways to mount drives where I can actually read and write data from the container that's running inside of a pod. Okay. So one of our best practices is, and actually, let me make sure I notate this too. So one of the things with volumes in the cloud provider setting is utilizing the network manageable options that we have. EBS, EFS on AWS. You have same type capabilities existing out there on Azure, as well as Google Cloud as well. Okay. The other, I would say, it falls in line with a best practice is going to be basically leveraging a cloud provider. Okay. And the reason is that they provide the control plane for us to help us manage that, so that so that you and I don't have to worry about redundancy at that level in our infrastructure. So using a cloud provider, at least in my most humble opinion, is a best practice. It really is today. There's really not, I can't think of a lot of reasons why it would be important for me in my own data center to stand up my own Kubernetes cluster and manage it from, low level all the way up. That just doesn't make a whole lot of sense to me. Okay. The other one that I mentioned in regards to namespaces, if I remember correctly, is don't deploy to the default. Okay. And I'm keeping a running list now. Should have done that at the very beginning. There's a lot of best practices, right, that we always bring up. At least I do when I'm working with customers. Okay. And yes, Kirk, great question too. And that is or great comment. It's fairly straightforward to move from EKS to AKS, reliably transferring control plane metadata from AWS to Azure. The beauty about this, and actually I'm going to put this in there as well. One of the things that is going to be helpful regarding the metadata, okay, is the metadata is transferable. There will be some of the manifest files, the YAML that you're probably going to have to modify because the technologies on, let's say we're moving from AWS to Azure, the technologies for storage are named differently on Azure, right? You get the idea. But when it comes to the metadata itself, that metadata is going to be recreated whenever you actually deploy your YAML files onto your into your new environment. So if I'm moving from AWS to Azure, when I take my YAML files that I use to deploy to AWS, and now I deploy them onto Azure, it's going to recreate all my metadata for me. Okay. As far as moving persistent information, you know, that may exist on one to the other, that would be a you know, a cloud provider type of mechanism. Okay. All right. I don't know what the beep beep is, Jonathan. I promise you, it's not a sound that I'm making. Okay. But the other piece that I'm going to mention in there too, Kurt, is early on when we kind of kicked off discussing about K8s, was talking about the fact that Kubernetes has a relationship with boating, right? Helm, using Helm, in my most humble opinion, in the enterprise, is the best practice. Okay. And the reason is because Helm is going to assist me in taking all of my metadata and moving it in the event that I need to do that. Okay. I'll come back to Helm here in a minute. Okay. And we will we'll take a look at what it does for me. So all right. So we've got labels, annotations, basically controller components. We've talked about those, okay? We've talked about, I think, the fact that a cluster is a set of virtual machines. It could also be serverless, okay? Master node determines where and what is run on the cluster, okay? I'm gonna walk you through that real quickly in a minute here. And the cluster is configured via kube control, okay? It can also be configured through the Helm command. And I'm definitely jumping ahead of myself at this point, my friends, but you've seen me use kube control, and it actually communicates with the cluster and makes sure I have management capability to do anything I want, okay? Helm also will do the same thing, except Helm actually gives me a capability to work with repositories, and you'll notice that I have several different repositories that Helm works with. So I'm going to come back to this in a minute, okay? But Helm is a really, really super important component, right? Kube control is the main command line that we use to interface with Kubernetes, right? But Helm has slowly but surely become the package manager of choice, and I'm going to walk you through that, okay? All right. So let's talk about one thing that I mentioned too. That's going to be, I think, is going to become important maybe later on. And if I can, I want to make the comment that understanding the basics about Kubernetes is obviously important to actually utilize the framework, right? Understanding the intricacies of the components is going to make you a better user of them, okay? You're going to have a better understanding of them. It's going to help you utilize the infrastructure even more, okay? So I guess where I'm going with that, well, the reason I bring that up is that oftentimes I have folks that come into stuff like this and they're looking for the magic tip. And quite frankly, there's not a whole lot of magic above and beyond the fundamentals, but you become a better user of the infrastructure the more you know about it, okay? All right, so if you'll remember our master components, okay? the kube API server, which is essentially what kube control talks to. Okay, so whenever I issue a kube control command like that, it's talking to the API server to issue that command. The controller manager basically makes sure that whatever you deploy is deployed correctly. etcd, if you remember, is cluster state, and the kube scheduler basically it makes sure that things are scheduled onto the cluster. Okay, you can have more than one master node. Only one of those can be active at a time. So let me walk you through how scheduling takes place. So I issue this command where I do a kube control apply -f and then maybe service.yaml. Okay, that's one of the YAML files. So what is the flow and how this happens? That's a great question. So the first thing that happens is the kube control command is talking to the API server. And so whenever I issue that command, an entry is then put into etcd that has all of the manifest information, right? And then it also has a field that represents and states what node that manifest is running on. Okay, so in the beginning, okay, in the beginning, the node that my workload is running on is going to be blank. Okay, so what the scheduler does on a regular basis is it will pull the API server asking for entries in etcd that do not have a node identified where it's going to run that workload. And so when the scheduler gets that information back, the scheduler will then go through the process based upon CPU, right, and memory to determine where to run your new workload. Okay. So whenever I do that kube control apply, all of that is happening. Okay. Once the scheduler finds a adequate node to run it on, then the control manager will, or actually, excuse me, the scheduler will fill in the host name, okay, that field, and then the process that will actually deploy that workload onto the machine is initd. Okay, if you remember, we actually saw those components back here. Okay, or excuse me, not initd, kubelet. Kubelet on that node is going to see that the deployment field was filled in, and so it will kubelet deploy the pod on that node. Okay, so that's the process that Kubernetes goes through whenever it is doing any type of deployment. Okay, so you see how you actually can see how loosely coupled this architecture is, right? And anytime a workload is going to be scheduled, okay, anytime a workload needs to be placed on a node, it is always going to go through the scheduling, 100%, whether it's a new deployment or a deployment that had problems and is going to be redeployed. All right. So I'm not going to go through that piece, right? I want to come back to some other stuff here in a second. The nodes, basically physical, virtual, right? Virtual machines we've talked about. Those could be Fargate. They could be the pod. Okay. Pod is very important. Pod is our unit of work in Kubernetes, okay? It is one or more containers are running inside of a pod. Want to make sure that everybody's good with that, okay? The normal ratio is 1-to-1. Each pod gets a unique ID, okay? It is the way that the containers in my deployment are going to be managed, okay? The pod gets an IP address, okay? It's not at the container level, it's at the pod level, okay? And the reason that we use pods for grouping, or Kubernetes does, is multifaceted, okay? Part of it is decoupling, okay? And quite frankly, it really is straightforward, okay? All right, and I'll leave it open to you guys. If you have any additional questions, I want to make sure that you get those out here. Okay. Now, right now, I have a running pod sitting out there in my Kubernetes cluster. Okay. So I'm gonna go ahead and get rid of it. Okay. I'm going to change this up so that I can use deployment. Okay. You want another best practice? Okay. Use deployments. Okay. So the reason is I'll show you. Okay. So VI, let's look at the deployment YAML that exists out here. So basically what a deployment does is it rolls up all the configuration elements that exist inside Kubernetes, okay? So it allows me to work with labels, which we're going to talk about here in a second. It also allows me to specify replicas. Okay, I'm going to pause on that. So what replicas basically are is number of instances, Babatunde, WebAge should be sharing that presentation deck with you, my friend. Okay. So replicas are the number of instances of that pod. Okay. So replicas basically are the mechanism for scaling a deployment in Kubernetes. Okay. And I'm going to change this back to, well, hang on a second. Let me look at something real quick. Whoops. All right. Let me look and see if I should still have my two out there. No. Don't. Okay. You'll see in this deployment, I'm going to change the image to 1.0. Okay. It's a standard deployment it's a standard deployment in Kubernetes. Nothing totally 100% magical about this. Okay. That's beautiful. I'm going to go ahead and save it. Okay. Now I'm going to do kube control apply -f deployment YAML file. That's beautiful. Kube control get all. And you'll notice that it's going to start up my pod. You'll notice that it's going to create 5 instances of them. Okay, and so you'll see at this point I now have 5 instances of my pod running on my tiny little cluster. Okay, all right. So, and I'm part of this is fundamental kind of Kubernetes stuff. Part of this is going to be kind of best practices. Okay. So what I want to be able to do is I want to be able to access this application, right? Obviously. Well, I can't do it by default because pods are private. Okay, they're on their own network and they cannot be accessed from outside the pod. So in order to do this, I need to use a service, okay? So if I look at my service, how is a service associated with a pod? Well, a service is associated with a pod through the selector, okay? Or even better to put it, it's through the key value name that we give the pod, okay? So if you want to go back and look at that, and I'll look at deployment, notice what the label is, app equals Nginx. If I look at service again, what's it looking for? Well, it's looking for app equals Nginx. So this service is going to route a request, right, from that it receives to one of the pods that has that label. And, oh, by the way, it will automatically do load balancing, okay? All of the different service types in Kubernetes, whether it's cluster IP, node port, or load balancer, is going to do load balancing, okay? So here, node port, okay? I'll save it. kubectl apply -f service.yaml. All right. Then I'm going to do I'll do a get all again. I should see a brand new service out there. I do. You'll notice it's running on 31.914. Okay. So I should be able to do curl localhost 31.914, and lo and behold, you'll see that it comes back and tells me that we have version number 1, kubectl get pods. You'll notice that I have five pods that are currently running based upon my deployment that I've done. All right, I've thrown a lot at you with that one, okay? So labels, right, are the mechanism to be able to connect services with pods, okay? And by the way, I used one label in my example. We could make the match dependent upon multiple labels, okay? So I could have one label that specifies the name of the deployment. Then I could have another label that defines if it's prod, test, whatever I want it to be, okay? So the use of labels, right, is a really important item inside of Kubernetes, okay? I would almost label it a best practice, but quite frankly, you really can't use Kubernetes without using labels, okay? Deployments, on the other hand, are really, really super gigantically important for us, okay? All right, does anybody have any comments or questions at this point? Everybody okay with that? All right, so I'm gonna go back in and I'm going to edit my deployment, okay? So let's say that our application has been running, okay? Everybody is really excited about it, and it's getting a lot of traffic, okay? So what we want to do is we want to add more replicas of it, right, to handle the load. So I'll do kubectl apply -f deployment YAML file, and then I'm going to come back and I'll get all my pods, and lo and behold, what is Kubernetes doing for me? It's exactly right. It's updating the number of pods now that I have. Now I have 10 of those that are running. That service that I started is going to load balance across the original 5 and the additional 5 that I added into the deployment later on. Okay, so again, one of the huge benefits about this is going to be the fact that I can make changes in my deployment and I can apply those. And Kubernetes has no problem handling those. One of the things that I want to point out to you is that what makes this possible is that controller component. Whenever I made the change to this deployment, right, to this YAML file, basically the controller saw the change and said, oh, we went from 5 to 10. And so basically it makes sure that there are 10 that are running, and it will basically put entries into etcd. Then the scheduler does its job to find the location to actually run those additional 5. Okay. So I don't know if you're one of those people that have ever stayed up late doing a deployment in production. This is going to make life a lot easier. Okay. So kube control, undo deployment, and let me see. I think I've got it backwards. I may be using a earlier version, but basically yeah, these are my deployment commands: rollout scale, auto scale, replication controller. Yeah, I think I have an earlier version of kube control on this machine. That's a bummer. Hang on a second. Shouldn't be a problem. Because I think it's been around for a long time. But the idea is that because one of our best practices, right, is deployments. We want to use deployments to basically manage Kubernetes, right? Our applications, our workloads, all that kind of good stuff. Okay. So because we do that, we have the ability to get history information. We actually have the ability to get the to roll back. Okay. We can actually change deployments, which you actually saw. So let's do this real quick. Let me show you, if you're not familiar, kubectl. And I'll do this, and deployment, I think it's ng-inx. We do get all. I forgot its name, by the way, you guys. That's why I'm adding the deployments. There you go, nginx deployment. There we go. That's going to help me out. There we go. So basically what it does, it gives me status information, okay? So I can actually check to see what has and has not, okay? If I do a describe on it, it's going to give me information about, you know, the details of it. And I should be able to, I think I'm going blind on this. Yeah, there's an undo command for undoing a deployment, okay? Obviously you saw the, oh, I know, here's one too. How about this one? I know what it is, by the way. Too many command lines, right? So there's my history right there. So I really don't have a history to actually work on. So let's actually take this one step further, if that sounds exciting to you guys. Okay. Yeah, I know what I see what I did wrong. So I'm going to go to deployment. and I'm going to come down here and say, oh, we're going to go to version 2.0. Okay, I'm going to save that. Then I'm going to apply it. Like that. Fantastic. And then I'm going to look at the history. You'll notice I have a version now. So what I will do then is I'm going to take the, and by the way, Perl localhost, and it's what, 31914, 31914. So you'll see we're on version 2 at this point. That's fine, that's great, that's fantastic. I think I changed that. So what I can do is, instead of doing and looking at the history, I can undo it. Oops, sorry about that. So by doing an undo, what that essentially does is it takes my deployment and essentially rolls it back, right? So just in case you're one of those people that had any type of situation where you had something bad happen in a middle of the night, then thankfully, I knew I'd get there. Too many command lines, man. I'm telling you, that just drives me nuts. Yeah, so fairly straightforward to be able to roll back. Also, I can actually roll forward as well. Okay, all right. So labels, label selectors, annotations. We talked about persistent storage already. Quotas. Okay. Now, I think I've covered the fundamentals, right? At least I think I did. I'm going to give you another best practice, my friends. Use resource quotas. Okay, and I'm going to give you multiple reasons why. Okay, these are kind of the best practices that I've named so far. We've got 1, 2, 3, 4, 5, 6, 7. Okay, I'm trying to beat 10, maybe get you up to 20. Namespace is very important. We talked about volumes. And we talked about the parameters that we want to use with these. We want to use the shared storage model that the cloud providers basically give us. Okay, use the cloud provider. Yeah, we get that. No deployment to the default namespace. We'll talk about Helm here coming up. Deployments, and then resource quotas. Okay. So let's talk about what in the world we mean by resource quotas. And I think I should have those inside of this example coming up. Let me find it real quick. And I'm just going to turn it on. Oops. I promise you, I'll find it for you guys. Ah, there we go. I know what that is. I hate it when it does this, because then I get to go do this. Bear with me, bear with me. I don't know why we ever allow anybody to put a space in a file name that exists on there we go. All right, so we've talked about deployments, all this kind of stuff. We want to talk about resource quotas. Okay, in this particular scenario, okay, we want to actually take a look at, and these are some more advanced concepts, and oh, come on. Yeah, I don't know why I'm having a hard time. What is it, Wednesday? Yeah. There you go. All right. So, one of the beautiful things that Kubernetes gives us, and is literally a one of our best practices, is the capability to automatically scale. Okay, and in order to do that, we're going to need us, to leverage resource quotas. Okay, and if you'll remember something I said early on, and that is that the container that's running inside of your pod has full access to the resources that are on that machine. That means CPU, that means memory, that means disk, the whole bit. Okay. So what I really want to do is I want to set limits on what a particular container running inside of a pod can actually have access to. Okay, and this is an important conversation, my friends, from multiple angles. So this is one of our best practices: use resource quotas. And there are multiple reasons why we want to be able to do this. Okay, so you'll notice that in this particular section, there is 2 Nginx deployments with and without deployments. Okay, and I'm going to show the no limits first off. Okay, so this is a very basic deployment. You'll notice it has one replica. It's going to run Nginx, and then it also has a service defined in it. Okay, that's beautiful. Okay, so I'm going to go ahead real quickly and oops, didn't mean to do that. And I'm going to clean up my yeah. And I'll delete this deployment. Except I didn't need the F there, did I? It's not a file. All right. Let's go back and take a look at this. So it's terminating that. Then Control, delete. And then we're going to get rid of that Nginx service, right? Beautiful. We'll do get all again. And we should only have one thing out there. Beautiful. So you saw what the one Nginx deployment with no limits, what it looks like. It looks like a normal deployment. You've seen that before. So let's look at the other one then, okay? So with limits looks a little bit different, doesn't it? So the service definition stays the same, but you'll notice when it comes to the definition of the pod itself, right? The pod has a definition with limits that are put on both, and actually there's 2 different ways to express this. And this doesn't show you memory, it just shows you CPU, but I could have put limits on both of those if I wanted to. In this case, we're limiting CPU to 250, that we can request up to 250 space, but it can go only as high as 250. And by the way that Kubernetes does resource utilization like this, is on fractions of a CPU. Okay, so that doesn't mean an entire CPU. That's like a quarter of a CPU. Okay, Shalish, I appreciate the question. The limits, which is really kind of weird, right? Apply to the container that is running inside of the pod. It's not at the pod level itself. Okay, so where pretty much everything else is focused on the pod, like networking, stuff like that. When it comes to resource limits, this is at the container level. And I think if you're familiar with the way containers and Docker work, that actually makes some sense because that's the level that we want to be able to control, right? So let me see if I can find another example on this. Okay. Oh, this is so good. Not that. I don't know if I do. I don't know if I have an example that's going to show resources. Oh, there you go. How about that? So making sure that everybody understands resource quotas, right, are a best practice, okay? And so this particular pod example that you're looking at right here, it has limits for both CPU and memory, okay? So it can request up to an entire CPU, or actually the limit is that can get an entire CPU. The request for processing power can only be a half a CPU at a time. And then memory, think of that as megs. So 256 meg is what the request starts with, and the max that it can ever get is 1024. Okay, awesome. I think that's tremendous that we have that, and that I have this in this because since I'm in here. I want to show you this, okay? Use resource quotas. That's our best practice, right? Everybody's on board with that, okay? How you actually specify that is really up to you, okay? So you'll notice here in this, we've specified what the default CPU and memory is. We specified what the default request CPU and memory can be. We specify what the min and max is, okay? So what I want to point out to you, remember I mentioned to you the fact that one of the reasons we use namespaces is to be able to do stuff like this. This would be a configuration file that I would apply to a namespace to set the bounds that can be used for that namespace. So any deployment that's done to that namespace, right, has these limits to deal with, okay? That is a huge best practice. That is one of the main reasons, or one of the, besides security, one of the main reasons that we like namespaces. Okay. All right. So hopefully that makes some sense. Hopefully that in and of itself has value for your time being here, in my most humble opinion. All right. So resource quotas, right? That's one of ours. We got that. So the next thing that I want to do is, remember earlier when I took my deployment and I went from 5 instances to 10, right? So I don't want to have to manually do that myself. And I think that goes without saying, right? Nobody wants to sit around at their computer and say, oh, I need to add 5 more, so they go in and do that. What I'd rather have happen is I would rather have Kubernetes do that for me, okay? So if you're not familiar with it, there is a facility in Kubernetes called the horizontal pod autoscaler, okay? So in this particular case, with your vast knowledge on the way that Kubernetes scheduling actually operates, hopefully this will kind of roll right into that a little bit, okay? The namespace is going to take precedence, Albert. Container can ask for anything that it wants, right? But the namespace is going to take precedence. It's a great question. HPA, basically, what we do with it is that we're going to specify the parameters that tell Kubernetes when to add an additional instance of a pod, okay? Because we want to scale horizontally, right? That's why we talked about being stateless. And by the way, that's right. I forgot that was one of the items that I mentioned as a best practice as well, okay? So by being stateless, we're going to make it possible for Kubernetes to scale us automatically. So what I'll do is with HPA, which stands for the horizontal pod autoscaler, okay, it will determine based upon my settings. In this case, I set the target CPU utilization percentage to be 10. Obviously, that's really low, right, for a test. And basically what's going to happen is that when the CPU utilization of the pods that are part of the deployment that this is associated with breaches 10%, then what HPA is going to do is it's going to go through the process of having Kubernetes create another pod for this deployment. Okay, so it will actually talk to the API server and go through that whole process, right? So what HPA allows me to do is specify min and max range, okay? Using a label, it's going to determine what this autoscaler actually applies to. And then it's going to use the target utilization range or configuration to determine when to actually add additional instances of the pod. Now, remember what our service does, okay? And remember that all services in Kubernetes perform load balancing. So as the autoscaler, as HPA adds additional pods to your application, then basically they will be available in the load balancer. It will automatically add them in. The beautiful thing about this is what Shalish is actually asking about, is that it goes the other way too. So when it drops below my utilization percentage, then it's going to start dropping pods. And the beautiful way that Kubernetes does this is that when it scales out or it scales in, it does not do it one pod at a time. It basically performs a calculation based upon the current load to determine how many pods are needed, okay? And it will decrease by that amount, okay? So Jonathan, you're asking another really super awesome question. 10% over what time period? So the time periods, and just so that y'all are really on board with this, the time periods are configurable, okay? The defaults are 3 and 5, okay? So every 30 seconds, the HPA is going to check statistics for utilization. if a scale out event has not happened within the last 3 minutes, then it will begin a scale out process, okay? It does the same thing for scaling in, but it's going to be a little bit slower scaling in than scaling out. So it will use 5 minutes. Hey, Ravindra, yes, it should be, I believe. All right, so 3 minutes out, 5 minutes in, and it doesn't do one pod at a time. It basically does it based upon a formula that Kubernetes HPA uses to determine exactly how many pods that it needs. Okay, so this is our best practice list, my friends. Use HPA. Okay, now, and I'll give you this list at the end, my friends. Okay, because I'm getting way more than 5. I just can't help myself. I always get a little excited when it comes to Kubernetes. But the other thing that you need to be aware of, in order for HPA to work, you need to install some type of metrics collection facility in your cluster, okay? The default metrics collection facility for Kubernetes is called metrics server, okay? Though you can use Prometheus to do the same thing. And we're going to talk a little bit more about Prometheus here in a second after we take a quick top of the hour break because I want to make sure that you're aware of that. But you have to have something that collects stats. It'll collect stats at the pod level and the node level, and it's required for HPA to actually do what it does. All right, so this is a great afternoon or top of the hour quick 5-minute break time. Let's take one, and we'll do a break until 3:05. Oh, that's perfect timing. Come back and then we'll wrap up our time. Let's continue forward. So, excuse me. The last thing we talked about was HPA, okay? And quite frankly, HPA is a critical component within inside of Kubernetes, okay? And Thomas, let me read up here. So Thomas, you're asking a great question, okay? So, and let's clarify what HPA is doing for me, okay? And this actually bleeds into a little bit larger of a discussion, okay? So HPA is used for scaling pods. So depending upon how you have it configured, you could have HPA scale down to 0, okay? It is possible to actually do that, okay? But remember, or not remember, but HPA configurations are usually targeted at a specific deployment. So if I had 4 deployments on Kubernetes, I can have 4 different HPA configurations, okay? Now I could on all of those specify that that 0 was a bottom number of pods, right? But remember, HPA does not control worker nodes, okay? HPA controls number of pods, okay? So, so if they're all gone, right, basically, and we have the min set to 0, then what Kubernetes will do is it will reduce the number of pods down to your min amount. Now, and since you brought this up, I'm going to actually, kind of leverage that. So assuming we're operating in a cloud environment, and assuming that the cloud integration component for Kubernetes is working correctly, which it usually does, then it's possible to have Kubernetes trigger the destruction of several of our processing nodes or worker nodes because they're not needed anymore. Okay, so based upon the question that you posted, HPA again doesn't control nodes, it controls pods, but the reduction in the number of pods could trigger the reduction of the number of processing nodes that exist in your cluster. Okay, so hopefully that addresses the question. It's a really good question though, really, really, really good. All right, so HPA, very important technology, and since I brought it up, I'm gonna talk about this too. You need some way to monitor your cluster, okay? So hang on a second, and I'm going to give you the. So you need some mechanism to actually do that, okay? So assuming that there's not a mechanism that's in place at this point in time, what I'm showing you right here is the de facto standard that we use for the Kubernetes world, okay? And the beautiful thing about this is Prometheus, which actually collects metrics, can be used with HPA. So if you're using Prometheus, you don't need to use the metric server, okay? But Grafana is the visual way to actually see the information, and plus it provides a way to do custom alerting and querying of the data that's being collected by Prometheus. So Grafana plus Prometheus, basically a huge, huge tool for us in the Kubernetes world, okay? Want to make sure that everybody is truly aware of that. And it also can supply the needed metrics that you may need to leverage, okay, for scaling, okay? All right. But again, just to make sure everybody's clear, HPA is focused on pods, right? Because it's a Kubernetes mechanism. It is possible for the number of pods to be reduced to where the processing power to keep your cluster up and running correctly can allow for the reduction in the number of processing nodes, okay? So the cloud provider integration would make that possible. And so it's a dynamic environment, and Kubernetes automatically adjusts to the number of nodes and the number of pods. Remember that every single service that makes it possible for us to access a pod's capabilities is tied to the pod through the label. Okay, labels, okay? Labels aren't necessarily a quote unquote best practice, but you cannot work effectively in Kubernetes without leveraging labels. And quite frankly, they are very straightforward, my friends. They are not overly complex, okay? So, all right, so requests and limits plus HPA, best practices, the resource quotas, that's best practice. There's a couple of other things that I want to cover with y'all in the time that we have left that I think is pretty important, okay? Metric server is with K8, so metric server is provided with K8, and so why would I switch? All right, so hey, Kirk, metric server is available, okay, for your Kubernetes install, okay? It's not installed by default. You're going to have to install it yourself, okay? Is it free? Yep, it's 100% free. Is Prometheus and Grafana free? Yep, they're 100% free. So you asked a really super good question, Kirk, on why would I choose Prometheus Grafana over Metric Server? Metric Server is fairly straightforward, okay? There's really only a couple of metrics that it really is concerned with, and that's CPU and memory that each one of your pods is taking up. Prometheus, on the other hand, and the combination with Grafana, we can monitor both CPU and memory, but we can also monitor everything else that goes along with a pod. Web traffic, number of requests over the last 5 minutes. You get the idea. So basically, Prometheus is a superset of what we can actually accomplish with metric server. Okay, so hopefully that makes some sense. Okay, all right. So all right, a couple of other things for us that I think are really super important, and these fall under some of the content, but that as far as information about Kubernetes, but they're also best practices. Okay, I think I can. Yeah, I can. I think I can adequately say that all of the best practices that you may know about creating containers, right, and working with just pure Docker really apply to the Kubernetes ecosystem. What I mean is doing things like paying attention to the size of your container images, right, and things like that. So best practices that we follow for regular containerization also applies here. I think that makes some sense. Okay. I think one of the other things that we want to talk about is security. Okay. And I'm going to come back to another performance item, I think, here in a minute. But RBAC, okay. Basically, Kubernetes operates on a role-based authentication type of a facility. Okay, so there's a couple of things that I want to comment on here. Okay, so use RBAC and use external secret storage. Okay. All right. So what I mean by this, okay, is role-based authentication is exactly as you would expect it to be. Okay. So if I look at the dev role, okay, YAML file, you'll see how the role-based authentication is done. Okay. So if this role is assigned to you as an individual, or you're part of a group that this role is assigned to, that means that you can get, watch, and list pods. You can't create them, you can't modify them, but you can get, watch, and list them. Okay. The other one is that you would have access to would be services. So with that resource, you'll be able to get, watch, and list services, right, as well. So in other words, it's role-based capabilities, okay? So for this particular role, I'm providing the capabilities that your user can do, okay? Very, 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 very important, okay? So I'm gonna look at this file, okay? Of course, I have to be able to type in the commands correctly, okay? Come on, John. Jeez, please, dude. It's only Wednesday and I'm having problems typing, right? All right, so you remember what the dev role had in it, okay? it had roles associated with pods and services, okay? So what we need to be able to do is we need to associate a user with a particular role. I think that makes sense, okay? So you'll notice here, this is what we call a role binding, okay? This would bind the role devs with a user named test user. There you go, okay? Now, would I use this in production? Absolutely not, okay? This information would come out of your LDAP server or whatever your security tool is that you use, okay? This would come out of Active Directory, okay? So I can actually use that as well, okay? So this basically, by the way, is the file to create the user that you saw. So this is not a difficult one, my friends. Use role-based authentication. Do not leave pods open. Don't assume just because it's behind your firewall that everything's protected. And you remember one of our first best practices that I mentioned right here, namespaces? Don't forget that role-based authentication can be associated with namespaces. So what that means is I can specify the fundamental roles that are available to anybody that accesses an application in my namespace, okay? So it makes it possible for me to set some defaults. I hope that's clear to you guys. So set the defaults at the namespace level. Use that namespace because it's really intended for security, right? That's one of its main mechanisms, as well as name collision, and then use RBAC for roles that are beyond the fundamentals, okay? The ability to like list and watch and do things like that, okay? All right, so RBAC, really super important, okay? All right, so let's talk about a couple of other items then too, okay? All right, so with this next piece that I want to talk about, and by the way, there's an example, there's metric server right there. Metric server's on GitHub, by the way, if you're interested in it, right? Creating namespaces is really easy too, my friends, okay? See that namespace.yaml right there? There you go. That YAML file creates a namespace called advanced K8s. Obviously, I could add additional elements into it for configuration, but I think you get the idea, right? So couple of things that I want to make you aware of, okay? So you'll remember that one of the components that we talked about early on was the scheduler, okay? And the scheduler runs on the control plane, and the purpose of the scheduler is to identify where a pod is going to run, and that the scheduler by default, okay, uses and looks for available memory and CPU, okay? Now, let's assume that the scheduler needs to be more complex than that, okay? So let's assume that, excuse me, it needs to have more capabilities than just looking at the memory and CPU that are available on a machine when it actually determines where it's going to be run, okay? And I'm looking for a couple of files here. That's a controller, conformer. Let's see if it's in Init Containers. No, that's not the one yet. Hang on a second, you guys. Now, we talked about that already, I do believe. All right, I think we've got everything in here that I'm going to use. All right, hang on one second, y'all, because there's something really important that I want to make sure that I hit on. And it may be back in. All right, one other thing that I will mention, okay? And I think, yeah. Uno momento. Yeah, there's a couple of things that I need to talk about real quick. All right. So we're in the process of talking about scheduling, right? So I'm going to finish this up, and then I'm going to come back to something about security because it's also going to be an important subject to kind of finish out with, okay? But when it comes to scheduling, basically the scheduler in Kubernetes determines where a pod is going to be run based upon CPU and memory availability, okay? What if, okay, what if I want to use a more complex scheduling mechanism? Does that make sense? So actually, let me make it even more exciting than that. What if I want to have my pod that I'm trying to schedule only run on machines that have a GPU, okay? Or maybe I only want it to run on machines that have, you know, an SSD drive, okay? Or maybe I want to influence scheduling based upon other pods that are running in that region in AWS, okay? So in other words, I have some different scenarios that I might want to enable beyond just CPU and memory, right? So the question is there a way to do that? And the answer is yes, there is, okay? So you'll notice I have a file in here that's called Affinity, okay? And what you'll notice in here, and this one's pretty basic, but I think it kind of shows the elements of what that can be done. You'll notice that under the specification where this is going to run, okay, it has what's called a node selector, okay? And basically that means exactly what you think it means. It says node, okay? And so it's going to run this, it's going to run this node, or excuse me, this pod on the node that has a label of disk type equals SSD. Ooh, so basically you and I can influence scheduling of our pods, okay, through affinity rules, okay? Let me show you some others real quick. These are really, really, really good. So the affinity YAML file shows you exactly this. You'll notice this is really, 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 really super awesome as well. So affinity can be oriented towards the node, but it can also be oriented towards another pod, okay? So basically this affinity rule looks for a label where the app is called it says app equals store, and then you'll notice there's a topology key there. So what this is going to do is make sure that this pod is started on the same host where this pod is already running. I'm sorry, that's just really. So there are different scenarios that you and I can actually implement beyond just the standard scheduling, right? For CPU and memory. Okay, so I can do it based upon all different kinds of mechanisms, my friends. It can be related to the node. Okay, it's not uncommon in some of my customers where they have container logic that really needs a GPU to actually perform. And so whenever they're deploying that container in a pod, inside the manifest file, they'll specify the key for affinity that says that the machine should have a GPU level or label, okay, to identify it that it has a GPU on it and all that kind of good stuff, okay. So there's quite a bit in that that can be leveraged. Okay. Let's see. Let me see if there's anything else in here that. Yeah, the node affinity. Okay. Right. So basically, in this particular one, containers. Yep. For this, this is actually doing a node affinity, okay? And it's when the nodes are actually labeled with team values, right? It can be used to determine where they're going to be deployed at. And the Jonathan, you're asking a really good, really good question. So, so if I'm going to look at the pod. Let's see. Yeah, I'll look at a pod affinity rule. Wow. Yeah. So if I look at a pod affinity rule, so you'll notice this right here, okay, that topology key. This is what Jonathan is asking about. It's a really good question. And the answer is yes. The cloud provider provides topology keys. And I should have started up an instance of EKS before we started our time together. I could have shown you. But for instance, on Amazon, Amazon for each one of the for your cluster, it has topology keys for host name, region, availability zones, the OS that's running on the machine, how big the machine is as far as what its CPU capabilities are. So there's quite a bit that can be done. So you can see, I think what I'm kind of, throwing at you is that there's quite a bit that can be done to influence scheduling beyond just basic CPU and memory. Okay. All right. I'm assuming everybody's okay with that. So yeah, SSD, GPU, yep. And you know what the best part about it is too, which I don't know if it's the best part about it, but a good part about it is if the label doesn't exist, you can add it if you need to. You could actually write a quick script to add that if necessary. Okay. Let's see. Two more topics that I want to run through with you. Okay. So the first one has to do with secret information. Okay. And then I'm going to come back to something a little bit more exciting. But secret information, basically referring to keys. When I talk about secrets, I mean username and password, keys, all this kind of stuff, okay? Let me see. Kubernetes actually has a mechanism for managing secrets, okay? And actually that doesn't show you in here, okay? But the secrets allow me beyond just putting stuff in for property files. The secrets are there to make it so that they can't be easily stolen. Okay. So what I want to and what I have put in kind of our best practices right here is you'll notice that whenever you're using RBAC, you should use something external for your secret storage. So I guess kind of where I'm trying to land this is that Kubernetes did a really good job. The team did a pretty good job on differentiating between property values that are used for configuration and stuff like that versus things that should be kept secret, okay? The problem is that the secrets would often find their way into files that were checked into version control. And by the way, I know that you know that that's bad, okay? So several companies have come up with opportunities to integrate their secret storage into Kubernetes. One of those is HashiCorp, okay? HashiCorp has a vault that can make its secrets retrievable by Kubernetes at runtime, so none of that secret information ever makes it into a file that then potentially would be checked into source control, okay? Hopefully that makes sense. Hopefully you get that, right? All right. There's one more thing that I want to cover real quick, okay? It has to do with Init containers, okay? Well, before I do that, let me see if I have this. I should. I know I do over here. Deployments, config affinities, services. And I can see if it's in the no, it's not there. All right. I'll talk you through one piece of it, and then we'll look at its capabilities in another, because I don't see the example. All right. So Kubernetes has a mechanism for all pods, okay, and the containers that are running in them to determine two things, okay? By default, Kubernetes determines that a container or a pod is running successfully and it has not died by just basic OS type stuff, okay? Is the process running and can it be accessed? But Kubernetes added on to that and made it possible for you to integrate into that what's called an init container and a status container. So an init probe and a status probe, okay? So the init probe basically determines when the pod can start receiving requests, and the status probe is used to determine if the pod is successfully still up and running. I think that makes sense. The problem is that if we try to use those for determining that our entire application is online and ready to run. It's really good for individual containers, individual pods, but it's not really that good for something that's a little bit more robust, okay? So in order to solve that problem, okay, we have this concept called an init container, okay? And so I'm going to show you what an init container looks like. In this particular case, the init containers are built on the BusyBox image, and they just use a command that's specified in the deployment file. Technically, they don't have to be that way, but you get the idea. So basically, to interpret this, what this means is this is your main container right here, okay, inside this pod. But requests will not be routed to this pod until both of these init containers have successfully executed, okay? So in the event that the NS lookup for my service is not running correctly, then this container will not start. In the event that my DB can't be identified, right, and determine it's up and started, then this container won't start, okay? So if you look at the Nginx YAML here, here's the service, and actually this is doing a similar component. Let me see if I see services YAML here. Yeah, there's my DB right there. And then there is the service called my service, okay? So basically, when the init can see both of those services, then it will basically allow Kubernetes then as an infrastructure to start routing requests to this pod, okay? So init containers are really kind of important components. Use init containers. This is a best practice, my friends, okay? Don't just rely on status probes and init probes, okay? Readiness probes, that's not going to be enough. Init containers are your mechanism for determining that. All right, so namespaces, we've talked about readiness, liveness. We've talked about limits, right? We've talked about RBAC. We've talked about the basics of your Docker best practices, right? That you probably already know about. We talked about using a cluster that is supplied by a cloud provider, right? Multiple nodes, all that kind of good stuff. All right. So I want to shift gears just a little bit, and I want to talk about a couple of items for the quote-unquote future. Okay, and I'm going to give you a link that, in my most humble opinion, is going to address quite a bit of it. Okay, so this link right there that I just gave you is this screen right here. Okay, many Kubernetes operators are not familiar with this, or developers are not familiar with this concept. Okay, so inside Kubernetes is essentially made up of a bunch of manifest structures, right? Manifest structure for deployment, pods, services, you get it. And we basically said in our time together that using pods using deployments is the best practice, okay? But what if there is something that is not adequately expressed in one of those formats? What if there's something that is beyond that, okay? Well, that's where the operator comes into play, okay? When we talk about futures in Kubernetes, okay, this is kind of what we see happening. So think of Kubernetes K8 as a base infrastructure that is going to allow us to build just about any type of solution that we want to on top of it. The problem with that is that there has to be resource definitions for all the components that we may want or need. How can we make that happen? It's a good question. It's a real good question, as a matter of fact. And that's what the operator pattern does for us. I more than encourage you to get familiar with the operator pattern, okay? Probably the most popular operator pattern implementation that we today use with Kubernetes has to do with Prometheus and Grafana, okay? Prometheus and Grafana have an operator implementation that allows us to, do the installation of it, okay? It has all of its customized resource definitions. It has all of its custom code. Everything is included in kind of one component. So when we talk about futures, okay, futures basically is, a lot of it is around custom components, okay? And I am making this into a list, by the way, so that I'll have something to kind of, so custom components, right? So futures, custom components, right? And I'll put in here operators, really super gigantically going to be important, okay? So that's number one, okay? The second element that you're going to actually see, I think, because of what we can do with operators, right? I think everything begins there, by the way. What Kubernetes really does not have right now is a mature API gateway, okay? So if you're familiar with AWS, Azure, GCS, they all have, API gateways, okay? This is what the ingress controller was supposed to be in Kubernetes, okay? And I'm going to say ingress 2.0, okay? So one of the key elements that we should be seeing in the future is a brand new ingress controller mechanism that's going to make it possible for you and me to use one type of service and route to any backend pod that we might want to, okay? Right now, our services, for the most part, are usually tied to a specific type of pod, okay? What an ingress controller will make possible for us is it will make it possible, and actually ingress controller 2.0, it will make a high performance service that can route to many different pods on the back end, okay? So these are two big future items that we would expect to see inside the product in the coming months, okay? All right, I'm taking every bit of that and I just dumped it out into chat, my friends. So the first part, starting with namespace, those are kind of our best practices. And actually, I'll title that for us, right? Best practices, right? And the bottom part has to do with two of the big futures. And by the way, the operator pattern is huge, gigantic. All right. What questions, comments, anything that you have that we want to wrap up before the end of our time? Let's see, Jonathan, products like Kong, yeah, it should. Yeah, the API gateway really should become the mechanism inside of Kubernetes to route to backend pods. So right now we use ingress controllers for a lot of that purpose, right? What we really see happening is that being taken away. Rancher is really good for managing your cluster. It is. I actually use Rancher with a group of folks in class. Rancher does put a level of abstraction between you and the cluster itself, but it does allow us to, from one location, manage multiple clusters from one kind of UI. So yeah, Albert, for what it's worth, I would throw Rancher in there as well. Not necessarily as a must-have, but as something that should be looked at. Okay. And Bombsy, yeah, I'll work with WebAge on that. Okay. And the content that they have for you guys, you should have a lot of this stuff in there to begin with. So we'll make sure that you're taken care of. No worries. Y'all have been great. Other questions? We got about 12 minutes or so. All right. If not, hey, it's been great having you. I hope it's been worth your time. Hopefully we'll get a chance to see each other maybe in a class in the future. You know, go out and share the best practices and love of Kubernetes.